This is the start of the meeting. I'm just going to pause it till people come in. So I'm going to share my screen. Okay, so next slide. Okay, so backyard accessory residential units have limitations in delivery and installation that open field site units do not. So I've looked at a number of options for a small two-bedroom ARU in a downtown area and in other areas. So I was talking about modular units. So if we have a modular unit built in a factory, typically for 850 square foot, they would do two halves, 40 feet long and 10 feet wide, and they put them together. You can build these with wheels on them. So they've got three sets of wheels with, three axles each, the ones I've seen. And you can move them into a position with a tow motor. And so here's a picture of one I saw. And the trouble was, you can see the ruts in the mud on the lower left. You can understand this come planting season. You're trying to do this trailer that's on wheels, and they're not tractor tires; they're just regular highway tires, so they sink into the mud. Anyway, I'd never seen this kind of a little tow motor. It's remote control. See the guy with the red shirt on the right? He's got a remote control, so nobody drives this thing. Have you seen one of these?
Oh,
So this is what they're using now, with high tech. It's a little robot, and so the frame of this trailer or this modular home is designed to be moved from front and back and lifted up and down. Uh, so there's a whole video on how you do this, and they were commending the guy for getting around that little tree on the left, but it's basically a wide open site. So, that lends itself to open field construction, not somewhere like a backyard in a downtown urban area. So another one is the same factory built unit, but you install it with a crane. And in some places, you may have a house in the way. So you've got to lift this unit, each half, over the house. Hope there's not too many obstructions. Have you ever seen that, Jim?
yes.
And a person up the street had a tree that needed to be removed, and with our new bylaw, you got to pay money to get a permit to remove a dead tree. Anyway, she called Davies Tree Service, and they charged her $15,000 to use a crane like this to reach over and have a bucket with the guy with the chainsaw to cut up the tree and remove it. So this is obviously expensive. Then you have these, a typo there. Anyway, foldable units that can be delivered on a standard truck and moved into a place with a crane. Then you unfold the units. And there's a bunch of these from China. So here's your tractor trailer, and it's a container that was shipped from China. It's got a fold up house inside it. You just pull it out with your little backhoe or your crane or whatever you've got. No trees or buildings in the way. Plop it down on your pad. Then you unfold it. Then sometimes a little backhoe may come in handy. Now you've also got factory modular components delivered on a standard flatbed and moved in with a small forklift or carried by hand. And when you mentioned the guy near you that's got a modular home factory,
Yeah.
see, sometimes they build a house in the factory, then they take it apart and put it on a flatbed. Anyway, in this case, you deliver all these pieces to the site, and because they're small components, you can maneuver them into a backyard situation where there's all kinds of trees and
So a
buildings.
question about your the, the foldable up one that comes from China. Um, is there any toxic materials used in there that aren't that are pro con the code? You know, like chemicals that vaporize over time, stuff like that. Because they,
Yeah, VOCs. Actually, I watched a video on somebody who was concerned just about that because it came from China. So they got all this monitoring equipment, somewhat like I've got for VOCs and particulate matter and carbon monoxide and hydro off gassing, whatever stuff is. Anyway, they found that it was very clean. So maybe they had toxic materials in the construction, but by the time it got delivered from China, it all evaporated. But nobody inspects this stuff, so it could be full of toxins. So I would be
did
concerned
I
about.
tell you about the floor guy up here that I met? I knew the name, and he said that compared to Canadian hardwood floors, which have zero gas emissions, the everybody, all the contractors that are building new houses are buying. They go to Home Hardware or Home Depot, and these skids of flooring are sealed in a heavy plastic. He says the reason they're sealed in heavy plastic is because they off gas. And he says you put that in your house and you're breathing that stuff in. And he says it has a lifespan of about 10 years and then it starts to degrade. And
Well, I
that's
know that uh, you triggered something. Yeah, this in China when they build new cities and nobody lives there. The speculators all pay to build all these buildings. I knew a guy here in Toronto who bought one, and I said, "Well, what's it like?" He said, "Well, it's just a shell." "What do you mean it's just a shell?" "Yeah, it's just a concrete box, 50 stories high with 1,000 units in it, and nobody goes near it for a year till all the toxins evaporate. Sorry, they come in and they finish it. They put in their kitchens and flooring, like you're talking about, but nobody moves in for a year because they want all the off gassing to dissipate. So that is a real issue. I think here in Canada, when you get hardwood from Canadian sources, you don't have that problem. We were pretty careful with what we did here because we used solid wood as opposed to laminates or other, plastic-based flooring materials. But yeah, and I remember there's a woman who was helping me do some stuff, and she said, I did a video, Jim, saying that the worst thing a pregnant woman can do is decorate the room for the baby because painting and flooring and wallpaper, whatever, has got lots of toxic materials, and you don't want to be exposed to that when you're pregnant. So yeah, that is a concern. Okay, but let's move on.
yeah.
So these are options that aren't, to me, all available. It's mainly just the last one. So now this is what we talked about last time: stick frame versus panels. So standard stick frame components are delivered on standard trucks with forklift or bobcat to move components. And this can accommodate obstructions, trees, utilities, buildings. So here's a guy building a tiny home, stick frame construction. Everybody knows how to do this. Um, Now you can build it on site too with panel construction as opposed to having, these fold up homes with panel construction like we were talking about last time. And they're easy to move around. So this is a couple of pictures from what I showed you last time.
Right.
So I did a detailed analysis of costing, and I was surprised that stick frame comes out on top.
Hmm.
So let's just summarize. So for an older urban downtown backyard, the most viable and cost-effective solution is on-site construction. Units are usually small and lower cost so that shipping and delivery can be a major part of the total cost. In other words, if you're building like a mansion or an apartment building, um, the delivery and shipping, installation is a small percentage, but not when you're buying a unit for like under 100,000. Anyway, so I looked at a stick built versus panel construction, and it showed me that panel construction can be more expensive due to the cost of the panels. You know, the installation may or may not be uh, cheaper. So if the panels are not finished, like some of them just come with bare exposed foam or OSB, then additional, by the way, I think I said OSB was open strand uh, board, but it's
Or
oriented strand board. I had the wrong term. Anyway, you know what we're talking about. So if you have just raw insulation panels and you've got to finish it with outdoor siding, roofing, and interior drywall and paint. And I just watched a video on doing wiring on these OSB panels. And they've got hollow chases inside them, and they mark them with um, a green line on the surface of these panels to show the electrician where the channels are. Then he's got to go to all this complicated math and construction where he drills round holes to put in a square box, and hopefully the round hole is diameter is bigger than the diagonal dimension of the box. Anyway, he says, "Oh, it's really easy once you get the hang of it." Well, to me, I think it's not easy for 99% of electricians. Anyway, um, other way is you just route out a hole, get sawdust all over the place and gases and whatever, the foam flying everywhere. So, this wiring can be an issue. Now, stick built can maybe not be as energy efficient because, you've got more air leakage or whatever. It depends on the quality of construction. But, when we're looking at a small unit, um, this isn't a significant thing. I think you're better to spend your money on cheaper appliances and heat pumps that are designed for small units and they only cost like $1,000. Anyway, you have to look at the total overall cost. So this is what I came up with, and I've got differing information from differing sources. Sometimes when you ask AI, it gives you a range from low to high. Sometimes it gives you an average in Ontario, whatever. So it was kind of hard comparing all these, but this is what I came up with. So we look at regular stick 2x2, 2x6s, because so in Ontario we need an R24, which has to be a combination of R22 uh, studs and bats plus continuous insulation on the outside to get your total R24. Anyway, you can't just. So I saw some guy building a house out of 2x8s. Well, that's fine in maybe California, but it's not legal in Ontario.
why isn't it?
Anyway, then you need an R31 roof. Now, this was all, I was just
Why
looking at
why isn't a 2x8 code uh, allowed in Ontario?
because you need, well, it's not part of the prescribed construction approaches. I guess because they don't want bridging. They don't want thermal bridging with studs. But if you go to 8 inches, you probably overcome that thermal bridging. But the code says no 100% thermal bridging.
What does
But
that mean? Thermal bridging.
well, if you have, imagine a stud, 2x4 stud, and you nail on, your exterior sheathing and put your siding on it. Now the cold air can push up against the siding and the sheathing, and then transmit through the thickness of the studs. It doesn't go through where the insulation is,
Right,
but
right.
so it's short circuiting. So the code now says to get R24, you can use 2x6s, like 2x4s aren't enough. Well, you could put 2x4s with 4 inches of rigid insulation, but the most cost effective apparently is 2x6s with 2 layers of 1 inch, foam board.
But the 2x8s would give you more insulation than a 2x6, wouldn't it?
Well, not when you consider this thermal bridging. Ed Marion, my friend, is an expert in this in passive house construction. And he gave me a lesson one day on how this all works. Anyway, if you
So,
want to keep things simple, you go with what everybody knows.
right, okay,
Anyway, so for this construction, the closest I could get was $20 a square foot. So again, this is walls and roof. I didn't address the floor because I thought the floor would be common to all of this, but it may not be. So whether you use joists with bad insulation or, these SIP panels, that's another variation that I haven't finished with. My feeling is the floor should be these insulated panels because you're going to put flooring down anyway. So this OSB panel on the floor is probably, and it's structurally sound, so it'll span, 10 feet. So you don't need all the sub framing. Anyway, that's not included here. It's walls and roof. So standard construction, you need your roofing as well as your siding. So I'm calling that finish. So the finish is what has to be done on top of the framing. So if you go with OSB structurally insulated panels, that's raw surface. So you need siding on the outside, you need a roof on top of it, and you need drywall on the inside that's taped and sanded and painted. So just those two alone, the cost I got, the stick framing was 64,000. Again, this is for an 860 square foot unit, and almost 50% more for the OSB. So the difference is, in this case, the finishing seems to be more money, and again, I'm not too sure why it wouldn't be the same with the stick framing, but that's what it showed me. So it may be more comparable, but right off the bat, the cost per square foot of the panels is more. And I looked into that. I said, why is 2 sheets of OSB on foam cheaper than 2x4s or 2x6s? So I looked up or calculated the total amount of surface area of a 2x4 versus an OSB, and the OSB I assumed was like ½ inch thick, and the 2x4, nominal is 1.5 by 3.5. So you're actually using less wood with stick framing than you are with this OSB, even though there's no intermediate framing. It's just a surface area 4x8 of cheap plywood in essence. Anyway, so I think that's why the materials are a little cheaper with stick framing. And apparently, nobody can buy 2x4s cheaper than Home Depot. Like the lumber industry is bottomed out that you can't go to some special contractors department store and get cheaper 2x4s than from Home Depot or
right.
Home Hard, any of these building supply materials. And I think the same with drywall. Anyway, then we look at these steel covered foam panels, and steel is more money. So they're almost twice the price of wood. And then some of them are painted and some of them are not. And some of them are ribbed so they look nice, so they're all more money until you get to the ones I showed you before.
Yes.
Just foam with the kind of metal channels every 2 or 3 feet. So that is less steel and more foam, but then you have to finish it again for like 28,000. So, I was kind of disappointed that it showed me this, but I think it's accurate. And when you're looking at trades, you can get people who know how to do regular framing. You get like this electrician trying to run wires inside of these panels, and he said he quit his job working in a factory in industry, like doing industrial buildings, to learn how to do this for residential because he thought he could make more money on his own doing this kind of construction. Anyway, you just don't get that many qualified people. So just to kind of wrap this up, so for small backyard ARUs, the cost of shipping and installation can reduce by using stick frame construction. Building small units is not as cost effective as building large units. So for me, I concluded providing a 2-bedroom house for 3 people can be much more affordable than a single studio unit for 1 person. So what Habitat for Humanity has got, and they've got demonstration units in Mississauga, actually across the road from where Vishwa lives, and he went over there and looked at them and said, "Oh, they're beautiful, Jim." I said, "How much are they?" I told you this. "Oh, they're $900 a square foot." I said, "No, $90. No, $900 a square foot." I said, "That's crazy." So it's 225 square feet. There's no bedroom. There's a sofa bed. We've been over this. Anyway, I'm just doing now an analysis for like a 2-bedroom unit for that, 850 square feet roughly. I think will come in when you look at renting it out and something that's affordable under this 3 times rule. It shouldn't be more than 3 times your annual income. Divide by 12, whatever. So, to go to try these little like tiny homes of 300 and 200 square feet, to me, just doesn't make economic sense. So I'm going to stop recording this. How do I do that here? I don't see where. Okay, I'm going to stop sharing recording. I'm just going to record this. So say that again, Doug.
I say that another type of vertical structure, point load structure, is called a helical pile. And the helical pile is a steel shaft with a big twisted blade on the end that screws into the ground. And
yeah, when I did my deck, I had this guy come in with this little like a stand-on drill machine, like no seat or anything, like not like a backhoe with an auger on it, because he could get down, 2-foot wide walkways, whatever. So he came in and he drilled the post holes, and then we just put in the wood posts and poured concrete.
you can't do that with a house. You can't put concrete post you can't put wood into a concrete surrounding. There was concrete and the wood have to be separate. You can do that for a fence post. You can't even do it for a deck. By code, that wouldn't be allowed.
I'm sorry. I'm staying corrected. Yeah, we poured sonotube with concrete in sonotubes.
And
yes,
then a bracket.
And then a metal bracket.
And then that makes sense.
Sorry, yeah. I was watching a video where they did this post like they're building a fence and they were doing it as a support for a house, which most of the stuff on YouTube is not legal. Okay, so But these helicals may be, especially in this area of Burlington, it's all sand. So, you're not into any rocks or anything like that. So I
Right.
think those are the solution. Even if you're in clay, they're going to be a better solution.
Yeah.
Jim, are you familiar with that type of footing?
I am, yes.
The only downside to the helical piles is they don't have much lateral restraint. So you sometimes have to do like cross bracing between them or something.
Um, so Jim and I spoke last Saturday about these different types of SIPs, and I hadn't costed them out, which I just finished doing before I started this webinar or Zoom meeting. So
I'm
um,
on a conference call, sweetie. Okay.
I've changed my mind.
Yeah. Okay.
So if you want to look at the results of this Zoom meeting, or I can just send you the PPT.
Okay. Well, let's have a look at the Zoom meeting first, and then yeah. So what have you changed it to?
Well, I think stick frame is the way to go for walls and ceiling, a roof,
Yeah.
but I'm not sure. I haven't analyzed it for flooring.
Well, at this
You
point,
need,
it depends a lot on whether you're going to do, if you're doing slab on grade with piers, um, then the SIP panel can sit on the slab and be fully supported. I don't, as you said, I don't know what it would do for spans. It is always, I think, a good practice to at least have a crawl space under a house and that way you can route piping and wiring and stuff in that crawl space and still have maintenance access. Um,
well,
I
my
mean,
idea is to have a wet well with a hatch in the floor in a utility room.
yeah.
But anyway, that's
And the purpose of the wet well is what?
to have your water, sewer, and electrical come up in one 2 by 2
Okay, so it's really
insulated
just
shaft.
you just mean a vault then.
Yeah, just an insulated shaft from, to go through the frost line of the crawl space and
Yeah,
into the unit.
right. Well, that's a possibility.
I was saying to Jim before you joined that I think this real problem here with cost overruns or expensive cost of housing is inefficient construction. Um, and I
Yeah, I
think the more you plan ahead, I was just giving an example when I was doing heat pumps, and I'd see guys come in, these HVAC trades, they had furnaces down to a science. They could put a furnace in a house in 3 hours. They'd spend all day going on smoke breaks and going for lunch and going to the bar afterwards. And the owner didn't care because he was making 100% profit. You'd buy a furnace for 2,000 and sell it for 4,000. Well, things have changed. Anyway, the point is there's a lot of inefficiencies in the construction industry. And Jim was saying, well, that's the difference between an entrepreneur and an employee. And if the entrepreneur doesn't instruct the employees properly, that's what he gets. Anyway, when we're looking at the low end, that's why I kind of discounted all this modular construction and factory built. Because in most cases, you need an open site. And when you're in downtown Burlington with trees all over the place and 2-story houses, even a crane lifting a 40-foot trailer over top of a 2-story house with all the trees, isn't going to happen. So that's partly why I'm back to stick frame, because you can carry in the 2x4s, 2 or 3 on your shoulder at a time, depending how strong you are.
or
So
they
it
have
needs
they do
a
have
number of advantages.
they do have crawler type wheelbarrows too that as you it doesn't have a seat, but you stand on a little platform and
Yeah,
you can
yeah.
carry a ton of material down a narrow path with those things.
Well, I was just showing, let me just bring this up to share.
The other thing that's a possibility is if you have similar houses, you can pre-cut all the lumber so that um, they're not standing around measuring and cutting, you know.
Yeah, so do you see this?
I do. The backyard ARU construction options.
Okay, so here's why isn't it starting? Okay.
Technology is great when it works.
Yeah, it worked just a minute ago. Anyway, it's not going. So
Kind of
anyways, I'll just go through
like
here.
that.
So
I was just going to say
this
it's sort of
is
like the cartoon about the singing frog that the guy would only sing for him, and then anybody else showed up, he just would go bribbit.
yeah. So I did a kind of a YouTube research on this type of small house construction.
Yeah,
So
yeah,
this is a unit I hadn't seen. It's a remote control. See the guy on the right trying to get
right.
a signal on the red shirt.
Yeah,
So
that's
he's got a remote control for this thing.
yeah. That's kind of the type of thing I was talking about. They have those in different sizes. Some of them are ride behind, some of them have remote control as well. But
Yeah.
that's the
So
type of thing I was talking about.
okay. So then this is the another alternative. Well, there's no trees here. That's not downtown Burlington.
Yeah,
But you think of if you're building something that these boxes and you got four of them, two on the ground floor and two on the top, and you're spending $2 million on a house, the cost of the crane is incidental. But when you're spending something that costs 100,000, it's not. Um, and this is the one that these guys ordered this fold-up home from China. So it comes
right.
in a container from China. So you pull it out. Well, you need a crane. You can see just the straps on the right,
Yeah,
and then
yeah,
you drop it down on your pad and you unfold it. And these panels are heavy enough that the guy's using his front end loader. So these things don't work. And this is now again factory modules. They build a house in the factory, take it all apart and send it on a flatbed and plop it down. So that's maybe more possible. But when I started looking at all these insulated panels, the cost of them, assuming you can get them on site cheap, don't beat this stick frame.
right.
And see this OSB on the left and this ribbed stuff. Um, there's more material, more wood, more trees used to make these OSB panels than 2x4 or 2x6 framing. When you add up all the volume of wood, so the cost is cheaper in materials. Now, labor, I think the other benefit is these guys know what they're doing. At least most framers know how to frame 2x6 with rigid insulation on the outside and put on siding and roofing. These SIPs, I saw a program, an electrician didn't know how to do the wiring, so he starts drilling round holes because he's got a round hole saw to put in a square box, and hopefully teasing Jim that the diameter of the hole is bigger than the diagonal of the box, and it wasn't the first time he tried it. So of course
It
he has
just
to
he
hammer
just
the
needs a bigger. I was just going to say that he just needs a bigger hammer.
yeah. So I think so. This is my summary of uh, different type of SIPs, and there's different ones, and some of them are completely unfinished. Like the bottom one, it's a metal channel with foam in it, and it comes up to a foot thick. It's great for R value and low uh, air leakage,
Right.
but the panels can cost more than stick frame when you look at materials, and even though the labor may be a little faster. I've been getting, I said to Jim, I have to take this with a grain of salt because my numbers are coming from different sources, and some are, they give you maximum, minimum, some give you averages. But the trend is there that these SIPs, even though they may be a little faster to install, the basic unit, by the time you finish them and run wiring and all this stuff, you're ending up with a higher total cost. So here that, unfortunately, the stick frame came the winner hands down.
Can I ask you a question about your calculations there as well, Jim?
Yeah.
Did your calculations take into account the design cost for the building itself?
This didn't, but I do have a spreadsheet that does everything.
All
So,
right.
if the house costs, I'm trying to get it under 100,000. The total install is like 200,000. It's
Okay.
almost a factor of two between just the basic construction, like without, this doesn't include, this is just wall and roof construction, not the whole house.
Yeah, so
No
you're
plumbing, no wiring, no
no
nothing.
no floor, no foundation.
Yeah, but I
All
do
right.
have that, and I can share that with you. So I was working on that. My conclusion here is that you're better to build a 2-bedroom, 3-person house. In terms of the return for the investor or the person who wants to help the poor people, um, to get a reasonable return for what's a reasonable rent for the tenant. And
Right.
I've also got an option for the tenant to rent with option to buy over time, and it's not severing the property. It's creating, tenants in common as opposed to joint tenancy, blah, blah, blah. I've got a lawyer who's going to help me with that. Anyway, you have to look at the overall life cycle costs, and the other aspect is what are your operating costs over time. So you get an extra air change per hour with stick built construction, but you're only heating the house with 1,000-watt heater or a heat pump, which uses 1/3 of the cost of, say, the gas alternative, or at least the energy. So you have to look at everything in total. And
Right.
so I've been doing these series of um, Zoom meetings that I'm using as an easy way to record these and then post them up on YouTube.
Right.
Anyway, yeah, so I'm looking forward to seeing how we can proceed together. Jim's interested too. I'm meeting with these people on Friday who may have a large source of community members, especially in the Halton region, who want to put their money where their mouth is. I don't know yet, but I'm keeping my fingers crossed because 1,800 people have signed a petition to help the poor.